Today we're going to be looking at ellipses. Now, an ellipse is actually very similar to a circle. In fact, I am writing the circle formula down here right now just to kind of show you something. So here's our circle formula we just finished working with. If I go through and divide everything by r squared, just to put it in a different format, you'll see this r squared over r squared can actually be written as 1. Now, if you compare that to the two formulas of our ellipses, you should notice that these are very, very similar. In fact, the only difference is that instead of having these two r squareds, we have an a squared and we have a b squared. Now, let me just tell you something that I'm going to repeat a few different times, but a is always bigger than b. Since a is bigger than b, that's what's going to give us kind of these oval shapes. So we're going to get, kind of looks like eggs if you're not careful, but kind of a squished circle. Alright, so here I've got a couple better diagrams for you to look at, better than I could draw. So we're going to actually just kind of look at the different parts of an ellipse. Let's start with the center. Of course, the center is right in the middle. It's not always at 0, 0. But it is found by exactly the same thing we did with circles, by finding hk. And remember, h and k are the opposite of the values added to the x's and the y's, or subtracted. Now, let's talk about this major axis, because that's the next important thing. I am going to highlight, so if you're looking down at this diagram, I just highlighted the major axis. It is the longer axis, and the one that I just did is going left and right, just like the x's are going left and right. Remember, I said before a is bigger than b. So right now I'm just going to look at the a's. A squared is under the x. X goes left and right, which gives us this oval shape that's kind of like an egg going left and right. So when a squared is under x, the major axis is going to be parallel to the x-axis. Alright, now if you look at the other diagram, we have the longer axis going up and down. So, y's go up and down. If you look at the formula, a, the bigger value, is under the y value, so this time the major axis is parallel to the y-axis. I didn't write that very well. Alright, so the a is always, always, always associated with the major axis. So a is always with major axis. Now, we have something called a minor axis. So if you look down at these diagrams, the minor axis is just the shorter axis. And if you probably guessed it, the b squared is what's going to go with the minor axis. Now, we also have some more parts. We have a focus here and here, and I'm putting x's because I've kind of blopped over them. So I've got these x's, and if you see on these pictures that there's the letter C. Well, the way we're going to find this, and I need you guys to write this in, a squared minus b squared is equal to c squared. This formula, please make sure you guys write this down, because this is very important. Now, we've got A, B, and C. The vertex. So the vertex they are points that are on the ends of the major axis. So I'm circling those here. Alright, so the vertex is just the distance A from the center to the point on the major axis. Alright? If you look at something called the covertex, those are the points at the end of the minor axis. And those are found by using b, the distance b from the center to that point on the minor axis. Then we've got our focus. So we've got a focus, so we've got two of them, so they're called foci. And this is where we're going to use the distance c from the center to that point, and it's going to always be on the major axis.